Hi, how are you guys? My name is Karina and I am here to teach you a content lesson. So we are going to work on something called quadrilaterals and classifying them. So if you aren't sure what a quadrilateral is, the definition of a quadrilateral is a closed shape in a plane consisting of four line segments that do not cross each other. If you break down the name quadrilateral, quad literally means four and lateral means sides, so four sides. So any shape you see that is four sides, that's going to be a quadrilateral. A definition for something that wouldn't be a quadrilateral would be a triangle, which has three sides. A circle, it has zero sides. You're going to kind of get to know those properties of a quadrilateral and the shapes, and we're going to go over something very simple called a subcategory. And so today we are going to learn the definitions. So we're going to start by doing definitions. I'm going to break down a few of our simple quadrilaterals and we're going to go over those. So we're going to start with a square. So a square is going to be a quadrilateral consisting of four right angles who has all four sides congruent. And congruent means same length. So you're going to hear the word congruent throughout the lesson, and that is basically, like I said, means all same lengths, same size. And so next we're going to do our rectangle. So our rectangle is a quadrilateral with four right angles, which also has two pairs of opposite sides that are parallel. So next would be our rhombus. Our definition for rhombus or our diamond rhombus are going to be known for the same properties, same shape, it's just different names, just whatever you would prefer. But its definition is a quadrilateral whose sides all have the same length. Next, we're going to go over our trapezoid. A trapezoid is a quadrilateral which is defined as having exactly one pair of opposite sides that are parallel. Okay, perfect. So we have our definitions, we have our shapes, our main shapes that we're going to work with today. We are going to help categorize and classify them using Venn diagrams. So I have a little handout here that we're going to be using. A Venn diagram is basically a diagram that's going to help you with organization. You can use a Venn diagram with anything, honestly. You can do it in English class, you can do it in math class. I'm sure you can even do it in science class. It's a very helpful aid in any kind of environment, and I would definitely learn how to use them. It's very simple and it's very easy. We're going to go over how to do it today. So I'm going to start by just writing my name. Always write your name, you guys. Always. Always, always, always. Okay, so we have, this is a three concept Venn diagram. So three concepts means we're going to do literally, as it says, three concepts in each circle. So each circle is going to be one concept, two concept, three concept, and we're going to start by naming everything. So first we're going to want to title our Venn diagram. That way we know what exactly we are classifying, organizing, and that way we can kind of stay on topic. So we're going to title it today Quadrilaterals. Quadrilateral, and again I'm going to write down the breakdown. So I'm going to do quad equals fours, and then lateral equals sides. So it's going to be our main basis of classification today for our Venn diagram. So everything that's going to be classified within this Venn diagram on this paper is going to be classified as a quadrilateral, which means four sides. You're going to hear me repeat that at least 100 more times today, guys. I really just want to make sure you remember exactly what a quadrilateral means. So we are going to begin by naming our categories or our three concepts. So I'm going to begin with the first one right here, and we're going to name that category or concept A. So concept A is going to be all sides are congruent. So you wrote that there. So everything in concept A is going to be considered all sides are congruent. So everything that's going to be in that is going to fall under that property. And then we're going to go next to B. So I'm going to put B in this concept here. And B is going to be a shape with four right angles. A shape. Perfect. A shape with four right angles. And then we have our last concept, which is our last circle here, and that's going to be concept number C. I'm going to name that with a shape that has two sets of parallel sides. Has two opposite, there we go, opposite parallel sides. All right. So we have here, again, I'm going to break it down one more time. Our Venn diagram is going to be, all of these are going to be quadrilateral, and these are going to be main properties that we are going to organize and classify our shapes under today. So we're going to start with our main shapes, which I went over and defined. We'll go over those as we go through our Venn diagram again. I'm going to start with a square. So a square we know is a quadrilateral, so it would fall under our paper under any of these categories. We're going to go under. Okay, so it's a quadrilateral that has 4 right angles whose sides all have the same length, or are all congruent. It actually also has 2 opposite sides parallel. Okay, so we're going to look at our concepts. So concept A is all sides congruent. A square, we know by definition, has all sides congruent. So check, square would definitely be under A. And then we're going to go to B. A shape with 4 right angles. We know that the square does have all sides with 4 right angles, so we know it would fall under category A and B. And then a shape that has 2 opposite parallel sides, which we also know that a square falls under. So we know that it is a quadrilateral. It has A, B, and C, all concepts. It falls under that category. So we're going to look at our Venn diagram here, and we are going to find the area that has all of them overlapping. Since it falls under every category, every concept, we're going to find the piece of our Venn diagram that all concepts fall under. So we're going to put square in this little circle here, this little area, because it is overlapped by A, B, and C. Perfect. So when we go back and read our notes for our test or homework or whatever it is, we're going to know that since it's in this spot here, it has to be under every single category. So that's how you're going to read your Venn diagram. All right, next we're going to go with a rectangle. So we're going to go through our concepts again. So we know rectangle is a quadrilateral. It has 4 sides. So it's going to make it onto our Venn diagram. Let's see. Are all sides congruent? So we know for a rectangle, by definition, all sides are not congruent. The 2 sides here are always going to be a little shorter than the longer. So it is not going to fall under category A. So we know for sure it's not going to be in any of these circles that are overlapped with A. So we're going to go to B. Does it have a shape with 4 right angles? By definition, a rectangle is a quadrilateral with 4 right angles. So it will for sure fall under category B. So we know it's going to have a little bit of B somewhere. And then our last one is shape that has 2 opposite parallel sides. We do know that a rectangle, I even have a little cheat sheet for you guys. Right here, a rectangle has the 4 right angles and the 2 sets of opposite parallel sides. So we know that a rectangle falls under category A, or not A, B and C. So we are going to find in the Venn diagram where it overlaps B and C, but not A. So we're going to overlap it, and we're going to put rectangle right here. So that's where it overlaps B and C, but not A. So we're going to write rectangle in there. Perfect. All right. So now we got rectangle, and we are going to go to our rhombus. So we know by definition that a rhombus is a shape that has all sides congruent. So our rhombus will definitely fall under A. Concept A, where it says all sides are congruent. We'll go to concept B, a shape with 4 right angles. So under our definition, a rhombus is not considered a shape that has 4 right angles. A rhombus does not have to be considered a rhombus with that property. So it's not going to fall under category B. I also have a little cheat sheet here, and it shows you our sides are both opposite parallel sides. So our rhombus is going to fall under categories A and C. So we are going to find in our Venn diagram where it overlaps A and C but not B. So we're going to write rhombus in this area here because it is an A and C overlap without B. All right, rhombus. Perfect. And then we are going to go on to our trapezoid. So a trapezoid is a quadrilateral who is defined with exactly one pair of opposite sides. So since that is our definition, we know that all sides are not congruent. We know that it is not B, a shape with 4 right angles, because by definition it is not included. And we also know that it has one side of opposite parallel sides, so it will not fall under C because that has to have at least 2. So we're going to look at our Venn diagram, and trapezoid will not fall under A, B, or C. So instead of putting it in the circles, we're going to put it right on the outside because this entire Venn diagram is going to be quadrilateral. So it is a quadrilateral, we know, because it is a closed shape with 4 line segments closing. So it says it has 4 sides. It's going to be based under quadrilateral. So we're going to write it right here because that way we know when we read our Venn diagram later, we know that a trapezoid does fall under a quadrilateral. It just will not fall under those other categories or those other properties. Perfect. So now that we have an idea of how to set up our Venn diagram and how we're going to write it out, we know later on when we read it, we know exactly how we're going to read it. We're going to know a rhombus, since it's in this area, it's in A and C, it's going to have properties of having congruent sides and having at least 2 opposite parallel sides. We know for reading a square, it's going to have all 3 properties of the quadrilateral. And then we know rectangle, it's going to be B and C because we're going to read it and it's going to have that here with no overlapping of A. So our Venn diagram really just makes it easy to organize our thoughts, organize our shapes, and be able to come back and reread those later on and kind of have a better understanding. But we're going to do a little bit of a concept that's going to be a little bit more challenging, something called a parallelogram. So parallelogram by definition is a quadrilateral which has opposite sides are parallel. So we know that it has to have at least 2 opposite sides parallel. That's its only definition. And we like to call parallelogram something called a subcategory because it is a quadrilateral, but it also is a subcategory because it has shapes under that category. So a rhombus would be known as a parallelogram and a quadrilateral. So it's both. It can be named as both. Okay. No, it's kind of confusing. So we're going to write parallelogram. At the bottom of our paper here. And by definition, we know that it has 2 opposite parallel sides. Or just the opposite sides are parallel. So you're going to have at least 2 of those. So we are going to look at our diagram here. And we're going to look at everything since it's going to be the same definition as category C. We're going to look at all of the shapes that fall under category C, and that's how we're going to find out what shapes are going to fall under our subcategory parallelogram. So we're going to look at our Venn diagram here, and it looks as if we have a rhombus, a square, and a rectangle. So we're going to write them under our subcategory parallelogram and rectangle. So we know that by reading our Venn diagram that a rhombus, a square, and a rectangle, they all have opposite parallel sides. So we all know those are parallelograms. So we know that if we get a question asking what quadrilateral shapes are also parallelograms, we're going to know to either look at our Venn diagram, or once we kind of get more familiar with the properties, we're going to know to look under. We're going to know a rhombus, a square, and a rectangle are all going to be a parallelogram, as well as being their own shape. So it's really exciting, but we also know that trapezoid would not fall under that category because it has only one side of opposite parallel. Yeah, so it's really exciting. Our Venn diagram is our most helpful aid, I think, for concepts and classifying our quadrilaterals and our shapes. It's really easy to go back and learn and look at for studying, for homework, for note taking. I always do it for note taking. It helps keep all of my thoughts, all of everything organized. That way I can look back, read it really quick, and remember, you're right, this is what it would fall under. So I hope you guys had fun. Hopefully you learned a little something today. Thank you for watching. Have a good night.